Hi, this is part 3 of lecture 6. In this topic, I will talk about the MAC address table. So a layer 2 Ethernet switch uses layer 2 MAC address to make forwarding decisions. So basically the Ethernet switch is completely unaware of the protocol being carried in the data portion of the frame, such as they are not aware of the IPv4 packet, the ARP message, or any IPv6 network neighbor discovery packet. So the switch makes its forwarding decision solely based on the Ethernet MAC address. So the switch will first examine its MAC address table to make forwarding decision for each frame, unlike the hubs that repeat bits out all ports except the incoming ports. So basically when a switch is first turned on, no communication happened, so the MAC address table will be empty. So the MAC address table is sometimes referred to as a content addressable memory or CAM table. Now, in this slide, I will explain about the learning and forwarding process in the MAC address table. So first, let us look at how a switch learned the source MAC address. So every frame that enters a switch is checked for new information to learn. So the switch does this by examining the source MAC address of the frame and the port number where the frame entered the switch. So basically, if you look into this diagram, so host A starts sending frame. So basically, the switch will check the source MAC address of host A and the port number where the frame entered the switch, which is port number 1. So this is the entry that will be stored in the MAC address table. So if initially there's no communication happen, so of course the information is not in the MAC address table. So what happened here is the port number and the MAC address is added to the table along with the incoming port number. But if the source MAC address does exist, so the switch will update the refresh timer for that particular entry. So by default, the switch will keep an entry in the table for 5 minutes. So now, if the MAC address exists in the table, like for example, there's the same MAC address 000A, but it's actually in port 2. So the switch will treat this as a new entry. So the entry is replaced using the same MAC address but with the more current port number. So if previously we have the same MAC address but in port 2, so the entry will be replaced with the newer port number. So now in the figure, for example, PCA or host A is sending an Ethernet frame to host D. So in the example, it shows host A sends an Ethernet frame and the switch adds the port number and MAC address to PCA to the MAC address table. So let us look at the forwarding process. Now the switch already learned the port and the MAC address for PCA. So if the destination MAC address is a unicast address, so the switch will first look for a match between the destination MAC address of the frame and an entry in its MAC address table. So if the switch found the destination MAC address in the table, so basically they will forward the frame out of the specified port. But in this case, we can see that in the MAC address table, there is no information of the destination. For example, in here, PCA would like to send frame to PCD, for example. So, but there's no information of the MAC address of PCD and its port number in the MAC address table. So, what happened here is the switch will forward the frame out of all ports except the incoming port. So, you can see here in this diagram, so the frame is forwarded to PCB, PCC, and also PCD. So, hence the reason why you see that the frame is forwarded to all ports, port 2, port 3, port 4, except the incoming ports, which is port 1. So, now, as a switch receives frames from different devices, it is able to populate its MAC address table by examining the source MAC address of every frame. So when the MAC address table of the switch contains the destination MAC address, it is able to filter the frame out of a single port. So if you can see just now, in the PC, when the PCD has received the packet, has received the frame, so PCD will try to reply back to PCA. So the switch sees the MAC address of PCD in the incoming frame of port 4. So here, the switch then puts the MAC address of PCD into the MAC address table associated with port 4. So now, after the switch already populate its MAC address table as shown in the diagram, so next time, okay, so next time, if the PCA would like to send again another frame to PCD, so the MAC address table already contains the MAC address for PCA and PCD. So basically, there will be no broadcast frame because now the sending of the frame could be done in a unicast manner.